the victory! Thomas Edison! Was it Nikola Tesla? We got
Step up, you'll be shocked when I spit and start static. I'll rip your style and add it to my long list of patents. While you were busy digging ditches and burning bridges, I'm pumping out inventions, stacking riches. So go back to your pigeons. You're a geek, plagued by OCD. That's why there's just no putting it gently. I don't alternate my flow, I diss you directly.
I see a universe of infinite energy, but no potential for threat from this enemy. So you can call me Tesla, Nikola, impeccably dressed, giving lessons in electrical nemesis. This will be on the test, so confess to your thefts and let the whole world know what the Serbian did for the Wizard of Menlo. History is getting rewritten, and I have read your best invention was a way to steal cred.
The truth hurts, you're broke and washed up. Don't give a smidgen about your visions. If they can't make a buck, I conduct business. Understood, things you never could. So dope that I even make New Jersey look good. I'm on the record, I invented. You got duped there, I said it. Now bet you $50,000 that you'll never forget it. Without me, here's a taste of what this battle would be. No lights, no camera, no sound. See?
You fool! You think that you can touch me with this? You couldn't handle my gifts with your greedy little mind. What's inside mine was ahead of its own time. You did not steal from me, you stole me from mankind. It's a wireless transmission of truth, and it's a shocking real story of a biker with you. And if the people knew you stopped me from making power free, they would curse the Con Edison with every utility.
Oh, wow!
Okay, so we have talked a lot about light acting like a wave, but it turns out it can also act like a particle. And one example of that is the photoelectric effect. So that says if light of a certain level of energy falls on metal, then electrons are emitted from its surface. So having electrons emitted is a kind of a particle-like behavior. This was used in early photocells, which is a light-activated electric switch. So this explains how it works. So if you look at red has less energy than green, blue, and violet. And red is not going to meet that minimum energy level to let off an electron. Okay, so it does not meet that. However, the rest do. And if you look from left to right, green has less energy than blue, and blue has a little less energy than violet. And that is because of the energy of the photon. So you need to remember that if the photon does not have the minimum amount required, you're not going to get an electron off of that. And once you do meet the minimum, you only get one electron for each photon. The higher the energy of the photon, the higher the energy of the electron. And remember how wavelength and frequency tie in there. Energy is equal to Planck's constant times frequency, so the higher the frequency, the higher the energy, and that also means the smaller the wavelength. So what happens if the brightness or intensity increases? Basically, that just means you have more. You have more photons, so you end up with more electrons. It's not going to change the actual energy level because these are all blue, so they're all going to have the blue energy level, which is going to produce a specific amount of kinetic energy. You just get more of them. So this is related also to the atomic spectra. So in the late 1800s, they would fill a glass tube with a gas, a pure gas like hydrogen, and they would add some electricity to it, and it would glow, and it would glow a certain amount. So when they looked through a prism to see all the specific amounts, they saw these four distinct lines at these spots. So we got a purple, a blue, a yellow, and a red. And that was specific for hydrogen. So how does this happen? If we look at Ernest Rutherford's model of the atom, he found the nucleus, and he thought some electrons were circling around that very small nucleus. Well, his co-worker, Niels Bohr, came along, and this should look familiar from chemistry, and he said that they had to be at specific radii, okay, specific orbits. They couldn't just be at random places around, circling around, okay? And the further away from the nucleus they are, it meant they had higher energy. So this is how he explained that spectrum from hydrogen. Okay, so the photon comes in, and it's got a lot of energy, and so it causes that little red electron there, it absorbs that energy, and it jumps away. Okay, from level 1 to level 3, and then the photon disappears. But what happens next is that electron has to go back home. So it's not stable where it is out there, and so it falls back down, and when it does that, it has to let go of energy, and so it gives off a photon. That photon is regenerated, and it's at a specific wavelength, okay? So, however they fell gave that red, yellow, blue, and purple line. Specific energy, specific frequency, which makes it those specific colors, Okay, so that was another way to show that light can behave like a particle. Okay, so then came along Young, and he had an experiment called the double slit experiment. And the purpose was to determine if light has properties of particles or waves, because this was getting to be a big discussion in the scientific community. So these show the two logical possibilities. On the left, if light consists of particles, and you have two slits there through a screen that's blocking the light, you're going to see two lines of light. If it exists as waves, we know waves have interference, and it's going to come off like the one on the right. So what happened? This is what it actually looked like. And so it looks like it's supporting waves quite a bit. You can see all the constructive and destructive interference. That's a wave characteristic. You can see the lines of dark and bright on the screen. So that says, hey, light's a wave. However, there was a little piece right here that helps us show that it also acts like a particle. The more density of light, because those are the brightest spots, and that's right lined up with those the slits in this double slit experiment, that indicates that light can act like a particle as well. So this shows that light and matter can both have characteristics of waves and particles. So again, this is the dual nature of light. Dual means two. So it can be wave-like, it can reflect, refract, have interference, other things like that, but it also can be particle-like, which is shown in the photoelectric effect and the atomic spectrum.